using RStudio, most things you can hit tab and it should complete things. Oh, that's not doing that. So, yeah, it's just taking a minute. You get a choice of things, you just select the one you want, and that's the summary. So it just tells me that, you know, the mean murder rate was 7.78, whatever it was, murders per something of population, etc., etc. All right? So that's the summary. The next thing we have to do is principal components. So the basic principal components is just to do object, whatever you want to call it. I'm going to call it object, PRComp. Now I don't need to worry about the species column here. So in the iris data, I have to take the first 4 columns because the species column I can't use principal components on it because it's a character, this different type of column. So all I need to do here is do US arrests. Oops. Okay, and that's all I need to do for that. I don't need to stuff around with anything else. And so that's done the principal components. Right? I can do the scree plot. And as I said, if you just plot the object, you get the scree plot. Also, scree plot does that. And it'll look a lot better on your screen. Exactly the same. It didn't change because it gives you the same output. Looks a lot better on your screens because you've got like decent resolution. This is like 800 by 600 on this projector. Right? Looks like it's flaking out anyway. Okay, you can also in RStudio you can make the plots bigger. If you just click on that zoom button, you get nearly a full screen version. You can see what's going on a bit better sometimes. And you see for the US arrests, it's nearly all on the first principal component again, like it was before, like it was for the iris data. Okay, so the other thing we wanted to do was a plot a bit like the Euro distance plot. All right, and simply I can do that with object. And again, I need to extract the actual variables, and I want the first 2 principal components. So that's the X, that's the $X, brackets, comma, 1, colon, 2. That gets me the first 2 principal components. Okay? And I'm going to do type equals N. I'm going to say don't put any points on the screen at all. Okay, I can turn off the axes, I can do all sorts of other things. Maybe we'll turn off the axes. Okay, and I'll get that. Right, I could turn the labels off as well with xlab, whatever. And then I'm going to use text to actually write the city names. So I need to tell it where to write the city names. So I do object $X, comma 1, colon 2 again. And then I give it the city names. Now the city names are actually in the row names of the data set. Okay, and that's what it looks like on my awful screen. If I zoom it, you can actually see what's going on a bit better, but it's better on your screens because of the resolution. But you start to see things like, well, Hawaii's out on its own, but that's a bloody island. You'd expect it to be a bit different to everybody else. You know, California, New York, West Virginia, Vermont. Does any of this make any sense? I don't really know. I don't really know what the crime rates are like in the US, but you know, that's basically telling you points that are close. In this should be, I mean, this represents the variation, and we know most of it's in the first principal component, so really there is just one principal component of crime, right? And the first one will be a large amount of crime, right? Probably. All right, so that's what they come to. The other thing we can do is the biplot, and again we just do biplot of the object. That does that for us again. It's invisible on my screen, but if I blow it up, you can see what's going on a bit better. A little bit. All right, and pretty much what it's showing you is that assault defines the first principal component, and the others, urban population is kind of the second. Rape and murder don't have any much impact at all in this particular plot. So this dimension here is really about assault, and what you're seeing is more assaults from left to right, I think, the way it's set up. Right. And that's what it's decided is the largest thing. Now that's probably because there's more assaults than anything else, so there's a lot more variability in assault than there is in anything else, because the numbers are just larger, right? Because we didn't do scaled stuff. So we need to repeat the whole thing doing scaled. So let's do that. So basically I go back to the principal components. I don't know if I've shown you this. You can use the arrow keys to go back through the commands if you want to rerun them. And then you can use the arrow keys and edit them. So I can do object 1 equals PRComp of arrests, scale dot equals true. All right. Now I can go back and I can do that plot again. I need to change it to object 1 now. Find the text line, change it to object 1 again. Okay, it looks like rubbish, so we'll zoom it so we can see what's going on. One thing I've noticed straight away is it's flipped it. So Florida was over here, it's now over here, but that doesn't necessarily mean anything, it could just be reflected. But a load of other stuff has moved around as well. Where's Hawaii gone? It was like way out on its own originally. It must be in the middle now somewhere. I can't even find it. Here, it's moved in a fair bit. Okay, things have changed around a bit. Okay, let's look at the scree plot again. Now object 1. Okay. There's much more variation in the second principal component now. Okay? Quite a lot more. It's not just all in the first and then nothing. There's a lot more in the second and the third. So the scaling's made a big difference here. Okay? It's made a big difference. It's made a big difference to the plot. And let's look at the biplot. You're going to have object 1. All right, everything's changed, and so now you can see murder, assault and rape, they've all been given about the same weight on the first principal component, and they're all in the opposite direction, but that's just a flip. We don't really care about that, it's just flipped everything. And the urban population is pretty much what defines the second component as before. But now it's taken much more equal weight for those three variables, right? Whereas before, assault was sticking right out and murder and rape were tiny little things in here, they were getting no impact at all, right? And that's just because the assault numbers are so much larger, all right, they were swamping everything else. But by scaling everything, we've got rid of that swamping effect. Which is the right way to analyse this data? It depends on what your research question is. Right? I'm not saying one way is right, one way is wrong. It depends on what you're interested in. Okay? The other thing we needed to look at was how much variation was explained by these first two principal components. We just do that with summary. So if I do it for the first one object, probably can't see if I scroll up a bit, you'll be able to see a bit better. You see that the first two principal components explain in the unscaled data, so this is object, 99.3% of the variation is explained by the first two. Okay, if I do that for the second version, it's now only 86.75. It's still a lot, but the scaling has meant that the extra variation in rape and murder has come out as part of something that's detectable, whereas before it was just swamped by assault. Right? So it makes a bit of a difference. In fact, these are now not really variances. When you use scaled data, these can't really be interpreted as variances or standard deviations in the same way because the scaling has got rid of it a little bit. But they're still kind of, this thing still helps you get some idea of what's going on. All right? So that's all of the US data, that's all question 1. So now you can get on to do the NCI 60 data.
Yeah.
I'll